In this example of finding the tangent line of a graph using the power rule, this is going to be a very similar situation compared to the last two problems, where here we are given a function, namely x squared minus 2, and we're given an x value, but we are not given a corresponding y value. All right, so we need to find the equation of a tangent line at the point x is equal to minus 1. But we need a corresponding y value to do that. So how do we find the corresponding y value? So to find corresponding y value, you need y0 is equal to f of the x value that you are given. So notice here we don't even have a graph this time, but you don't really need one to do this. You just need your function and a point, an x value. So every place you see an x, you replace it with a minus 1. So we have minus 1 squared minus 2. So what does that buy us? That gives us 1, because negative 1 squared is 1, minus 2. That's just minus 1. So our corresponding y value is minus 1. So when you plug in minus 1, this x value, you get out this y value. Okay? So we're going to use that as we find our equation of our tangent line, because the tangent line is going to pass through the point minus 1, minus 1, because of what we just found here. Okay, so I'll write that. Tangent line passes through this point. That point. Okay, so now how do we find the tangent line? Here below I have rewritten my information here. The y0, I did not have that initially, but now I do. I know it's minus 1. Step 1 of the finding tangent line process. 1 is just find the derivative. So we need to use the power rule to find the derivative of f of x. How do we do that? Take your power, bring it down, subtract 1 from the exponent. So it gives you 2x to the first. But as always, you don't actually need to write that first power. You can just leave it as x. So it's 2x. The derivative of minus 2, since negative 2 is just a constant, that goes away. So you could say, well, it's the same thing as minus 0, but you don't really need to write that because subtracting 0 doesn't really do anything. So we can erase that. Our derivative is 2x. Okay? Second step, find the slope of our tangent line. So m, which is our slope of our tangent line, is equal to f prime of the x value that we are given. So you just plug your minus 1 into your f prime, and that's equal to 2 times minus 1, or minus 2. Okay, so that's the slope of your tangent line, and is also the slope of your original graph, x squared minus 2, at x is equal to minus 1. All right, they have that slope in common at that point. And I can do this, and I can say this without even needing a graph. So, and you can do the same for sure. So now we need to plug everything into our point slope form, which is y minus y0 is equal to m times x minus x0. And now you need to plug in all your relevant information. So we know what x0 is. That's going to be minus 1. We know what y0 is. That's also minus 1. So plugging in all relevant information, we have y minus 1. Be very careful with your signs when you do this. And then your m is the thing we found above. M is equal to minus 2. So we have minus 2 times x minus 1. Again, be very careful with those signs. Very easy to get tripped up with sign errors. Okay, so now handling the left-hand side of this, y minus 1, that's the same thing as y plus 1. Then on the right-hand side, I have minus 2 times x plus 1 for the same reasons. All I did was clean up the inside of this. All right? And then we can simplify this a little bit further by taking this 2 and distributing it into this set of parentheses. So it becomes minus 2x minus 2. The final step is trying to get y by itself. So we're going to subtract 1 from both sides. That way we have y is equal to minus 2x minus 2 minus 1, but that's equal to minus 2x minus 3. Okay, so our final answer is going to be y is equal to minus 2x minus 3. And this is the equation of the tangent line. And to be very clear, it's passing through the point, -1, -1, the point that we were given, okay? So since I don't have a graph above, I can't say like, hey, look, it's the chartreuse line like in the last couple examples, but that's okay. You can still find the equation of a tangent line without the need for a graph, and that's exactly how you do it. The graph in the last several examples was just to illustrate exactly what you were trying to find, the equation of a line passing through the graph at exactly one point. That's what a tangent line does. All right, so hopefully you found this video helpful.